Hello and welcome to an intro to limits. First up, just the general idea of a limit of a function at a point. Consider a function let's go with y equals f of x. And let's think of its graph. Then we can kind of imagine tracing along the graph and getting close to a specific x value. So imagine tracing along the graph and getting closer and closer to some specific x value. Then the limit, if it exists, at that x value is the y value the graph is approaching. So I have an example below. So consider the function graph below. What does it look like? The y value is approaching as x gets close to 3. So here's our graph. So we want to find x equals 3, which is here. And then we are going to trace along our graph and get closer and closer to x equals 3. So let's just start way over at x equals 1 and just trace along the graph. And as we get closer and closer to x equals 3, coming from the left, it appears like the y value we are landing at would be at y equals 2. And similarly, if we come in from the right, as we get closer and closer and closer as x comes into 3, it also looks like our y value is still approaching that 2. So it looks like the y value, it looks like the y value is approaching 2 as x approaches 3. So this is the idea behind a limit. Now, if we look at our graph, if we focus in at x equals 3 specifically, we don't actually have a point there. So note there is no point at x equals 3. We have our open circle, but it does look like the graph is getting close to, the y value is approaching 2, even if there's not actually a point there. So this is kind of the idea of a limit, is what does it look like the graph is doing or approaching. So again, let's consider one more function. So let's consider the function f of x equals 2x minus 4. As x gets close to 1, what does f of x get close to? So we can think of this just in terms of algebra, what's happening if we pick values very close to 1. So let's just this time take a slightly different approach. And let's just pick values close to 1. So pick values closer and closer to 1. So we'll have x and f of x and just see what happens. So let's start off with x equals 0. And then we'll go to x equals 0.5, 0.9, and 0.99. And then we'll do the same thing from the other side. So when x equals 0, we would be looking at 2 times 0 minus 4, or negative 4. When x is 0.5, we're looking at 2 times 0.5 minus 4, or negative 3. At 0.9, 0.9, we have 2 times 0.9 minus 4, and we have negative 2.2. And then if we do at 0.99, then we wind up with negative 2.02. And let's do one more just to see the pattern. At 0.999, we do 2 times 0.999 minus 4, and we get negative 2.002. So it certainly looks like, coming from the left, that we are getting very close to negative 2. If we did the same thing, then looking at values above x equals 1. So let's work our way down, starting with 2, and then let's go 1.5, 1.1, 1.01, and 1.001. Oops, sorry about that. So we'll have 2 times 2 minus 4, and we would be at 0. And then 2 times 1.5 minus 4, we're looking at negative 1. 2 times 1.1 minus 4, we are looking at negative 1.8. 2 times 1.01 minus 4, we are looking at negative 1.98. And then 2 times 1.001 minus 4, we are looking at negative 1.998. So from both sides, just looking at what's happening with the numbers as we get close, it does appear that we are getting close to negative 2. So we are getting close to negative 2 for our y value. So that's kind of the idea behind a limit. It's just what happens as we get close to an x value, what happens to y.